Welcome back to All This Math. This is Professor Parker. Make sure you are subscribed to the All This Math YouTube channel. Make sure you drop a comment down below on this video. Make sure you like this video, and make sure you share this video with a few people. All right. All right. Also, I want to give a shout out to Prairie View A&M University. I got one of my Prairie View A&M University sweatshirts on. Historically Black college, located in Houston, Texas. So if you hang out in Houston, you like Houston, show some love to Prairie View A&M University when you're in town. You know. Also, it should be noted that Sundiata Acoli, who we all should know, is a graduate of Prairie View A&M University. Sundiata Acoli was a member of the Black Liberation Army alongside of Assata Shakur and many others, namely, rest in peace to Zaid Malik Shakur, who was murdered on the New Jersey Turnpike by New Jersey State Troopers back in 1973. Actually, I should say assassinated. All right, but Sundiata Acoli was a student at Prairie View A&M University. Years before that, he majored in mathematics was a mathematician and ended up working for NASA. All right, earlier in his life, also Jacob Carruthers, the late Jacob Carruthers, one of the founders of ASCAC, the Association for the Study of Classical African Civilizations, also taught at Prairie View A&M University. So those are two people that I met. Well, I mentioned a few people, but definitely make sure you are familiar with Assata Shakur, Sundiata Acoli, Zaid Malik Shakur, as well as Jacob Carruthers, a lot of his writings and the work that he did. All right, now let's get into this. Also, one more person. I'm gonna name one more person. All right, I'm about to get into the problem, but let me name Percy Sutton. Percy Sutton is somebody else for you to study. Who is Percy Sutton? What is his so-called claim to fame? Percy Sutton was Malcolm X's lawyer, right? He was Malcolm X's lawyer at the end of his life. All right, and this in the year as I record this video in 2025, in March of 2025, this is the 100th anniversary of the birth of Omowale Malcolm X, or as some people know him as Haj Malik Al-Shabazz. He was born in 1925 on May 19th, 2 days after my birthday. All right, so I dropped some names on you. Now let's get into the math. So division. Now this is one of these problems that I might put you, if you follow me on Facebook or Instagram, you might see a problem like this on one of my notes, on my Instagram note, or my Facebook note, on my page. And I don't really intend for you to actually take out a calculator and do division using a calculator, or even do long division on paper. Even though that's fine if you do, that's fine. But I really want us to think about mental math techniques. All right, mental math techniques. So first of all, let's think about what division actually means. This first number is called a dividend. The second number is called a divisor. First number is a dividend, 387, and the second number is a divisor, 45. Now what we're doing in division is we're trying to figure out how many of the divisors can fit into the dividend. How many, I say it again, how many of the divisors can fit into the dividend? So in this case, how many 45s can fit into 387? How many 45s can fit into 387? So let's say you had $387 to spend, and you got to buy toys for a bunch of youth, right? A bunch of children, and each of those toys costs $45. And you got to figure out how many can you buy with that $387, right? So that's the type of question that we're doing. I think that's referred to as the partitive method of division, because there's two types of division. You got partitive division and you got measurement division. Partitive is when you're trying to figure out the number of objects in a group. Measurement division is when you're trying to figure out the number of groups. All right, so we're trying to figure out how many toys we could buy. We already know that each toy costs $45. So we want to know, so that would be the objects, the number of money, the amount of money in each group. And each group would be $45. So we're trying to figure out the number of groups. That might sound confusing. Don't even worry about it. I just want to throw that out there just to expose you to it, right? If you don't understand that part right now about partitive division versus measurement division, don't even stress yourself. Don't even stress yourself about it. Real talk. Don't stress yourself about it. But we're trying to figure out how many groups or how many toys, if that was a word problem. Because right here we just got numbers. This is abstract. But if you had an actual real life word problem, then that's when we use the descriptors like, is it partitive? Is it a partitive division problem, or is it a measurement division problem? You know. So at any rate, how would I do this? There are many ways to do this problem mentally, but I would do it this way. I would do what we call like a partial quotients method, right? So to speak. first thing I would do is I would say, okay, well, I know 45 times 10. I just naturally just multiply numbers by random numbers that end in zero because that makes the math easy. 45 times 10 is 450, right? That's too many 45s because I only got, remember, you only got $387, right? We're trying to figure out how many 45s can fit into 387, not go over 387. You want to fit into 387. Again, you want to fit into 387. You don't want to go over 387. You want to fit into it. So if you do 10 of them, that's too many because you're going to go over 387. So now I say, all right, well, I know I need less than 10. Less than 10 45s. Less than 10 45s. Because 10 45s is too many. That puts me at 450. So that's too much. That's doing too much. All right, so I say, what if I take 145 away? What's 450 minus 45? 405. 450 minus 45 is 405. I'm still over 387. That's still too much. I'm still doing too much, right? So nah, that means, and that was, if I tried 10 and they gave me 450, and I take one of those 45s from 450, I'm left with how many? 9. 9 45s. That means 9 45s is equivalent to 405, where 9 times 45 is equivalent to 405. That's still too much. That's still over 387, right? Now this is like the mental process, but I'm gonna write some of this down, right? So what did we first do? We said 45 times 10 is 450, right? That's no good. I take 1 away from 10, and I say 45 times 9 must be equal to 405, because that's 45 less than this. 45 less than 450 is 405. Now 405 is still too much. But then what happens with 45 times 8? I know that's going to be good, because if I take 45 from this number, I know that's going to be less than 387. It's going to be less than 387. It's got to be. It's got to be less than 387. So 405 minus 45, first I'm going to subtract the 5, and I'm going to get 400. I'm breaking 45 up, decomposing it into 40 and 5. 40 and 5. I'm going to take the 5 away from 405 and take me down to 400. Then I'm going to do 400, take away 40, that's going to take me down to 360. So what happens is I'm like, okay, so I know that I could fit 8 45s into 387. 8 of them. I know I could fit 8 of them. But I got some left over. I got a little bit left over, right? So then what I'm going to do is I'm going to say, all right, well, if I know that to be the case, then I know 8 is my whole number, and this is going to be a mixed number. It's going to be a mixed number because I have what's called a remainder. I got numbers remaining, right, that are between 360 and 387. So I say, okay, well, how much is remaining? You ask yourself, what's the difference between 387 and 360? 387 minus 360 is 27. So then I got 27 as my numerator, and I keep 45 because what happens is that's a fraction, right? So what happens is we're trying to figure out how many 45s can fit into 387. Now a whole 8 of them can fit into 387. A whole 8 of them can, right? That takes me up to 360. And then a fraction of another 45. A fraction of another 45. I'm going to say it again for emphasis because it's that important. A fraction of another 45. What's the fraction? It's 27 of them. 27 out of another 45 can fit into 387 because that's how much is the difference between 387 and 360. So that's why we got 27 over 45. Well, I shouldn't say that. I should say 27 45ths. Because if you say 27 over 45, technically, that doesn't really have mathematical value. That's just two random numbers. You know, it doesn't really represent anything. 27 45ths represents a fraction, where you got an object that's divided up into 45 equal parts, the denominator 45, and then you are focused on 27 of those parts. 27 is your numerator, 27 45ths. But you always got to ask yourself, can I reduce that fraction? Can I reduce the fraction? In this case, you can. And how do I know I can? Because, and also I got videos on reducing fractions in another playlist, right? In my fractions and mixed numbers playlist, in case you're wondering, where I go into even more detail than I'm about to right now. But I know the common factor between 27 and 45, the greatest common factor I should say is 9. That's how you reduce a fraction. You find the common factor between the numerator and the denominator. Between the numerator and the denominator. You find the common factor between the numerator and the denominator, which is 9, and then you divide the numerator by that common factor, then you divide the denominator by that common factor, and then you get your reduced fraction. Why is it called a reduced fraction? What does it mean to reduce? What does it mean to reduce? To make smaller, to make less. The numbers get smaller, right? That's why it's called a reduced fraction. The numbers get smaller. So this is going to become 8. The 8 don't change. The 8 stays the same because we still know 8 45s can fit into 387. 8 whole 45s, right? 8 whole groups of $45 can fit into 387. But then you got some left over. So that's a fraction of another 45. That's a fraction of another 45, right? That's why we got 27/45. But we about to reduce him. So we're going to divide each of these by 9 because 9 is the common factor. And this is why we got to know our multiplication facts. If you don't know your multiplication facts, this part is going to be real difficult. Whenever it's time for you to reduce fractions, you're not going to be able to figure out factors easily, right? And we don't always got to, we shouldn't have to rely on Siri or Alexa or Chat GPT or just ask somebody else. We should be able to use our own brains and figure this stuff out. We need to know how to figure stuff out. This is one of the benefits of learning math and being good at math. It's not always about the actual math problem. It's about developing the skill of being able to figure things out. Responsible human beings, whether they be children or adults, need to know how to figure stuff out. And it's far too many of us walking around here in the world that don't know how to figure stuff out. And then we become a victim to somebody that does know how to figure stuff out, that knows how to take advantage of people. You don't want to be that person. So this is why math, this is another reason why math is important, because it teaches you how to figure stuff out. We need to know how to figure stuff out and stop just sitting back saying, I don't need to know that. My iPhone can tell me how to do that. Yeah, all right. Yeah, all right. So anyway, 27 divided by 9, you need to know your multiplication facts. If you know your multiplication facts, then you will know your division facts. If you know that 9 times 3 is 27, you'll also know that 27 divided by 9 is 3. So then you got 3 right here. And if you know that 9 times 5 is 45, because you know your multiplication facts, again, I can't stress the importance of that enough. You're going to also know that 45 divided by 9 is 5. So you got 8 and 3/5. 8 and 3/5. So that's one way to do some mental math, doing division. I thought I was going to use the partial quotients method, but I actually didn't do that. Partial quotients is when you take the dividend and you break it down into smaller parts to make the division easier, right? Like I might have just randomly did. I mean, I kind of use partial quotients, but not really. Like I might have did 45 times 6, right? And then I might have said, okay, well, 45 times 6 is 270. 45 times 6 is 270. So then I say, okay, well, boom. I took 270 off of the 387. And now what do I have left? I got 117. I got 117 left. So then I got to figure out how many 45s can fit into 117, right? I'm creating, and that's like a partial quotient. That 6 is a partial quotient. It's a part of my larger quotient, of my final quotient, right? So when you deal with partial quotients, you take the dividend and you break it up into smaller pieces that are easier to deal with, right? So it's not exactly the way I did it right here. I might do another video where I do this, show the mental math using partial quotients. But I got videos on the channel and a division playlist that shows partial quotients in detail. I probably got some videos on here with my daughter Asada that you probably seen before, you know, showing her how to use partial quotients. But yeah, but check those videos out too. But like I said in the beginning, make sure you're subscribed to the All This Math YouTube channel. Make sure that you drop a comment down below. Make sure that you like this video, and make sure that you share. Don't be selfish. Make sure you share this video with a lot of people. Share this video with a lot of people. Share it with some children. Share it with some parents that are frustrated, right? Because they don't understand what they call the new math, what people call the new math, even though they really shouldn't call it that. But they're frustrated. They don't really understand. These videos will help them to understand, and then it'll create more peace in the household. All right? Remember we talked about too. Malcolm X, 100th birthday, 2025. Percy Sutton, graduate of Prairie View A&M University. Sundiata Kohli, also graduate Prairie View A&M University. Jacob Carruthers, taught at Prairie View A&M University. Also, Asada Shakur, rest in peace to Zahid Malik Shakur. And I'll see y'all on the next video. Peace.